With some wireless transmission solutions, you may be able to increase the capacity of an installed microwave link from 4 to 8 and then 16 E1 through software control. Adding another link to any site will require installing another complete terminal. Connecting traffic signals between these two terminals requires bulky and expensive patch cables with installations that are often prone to errors. As your network continues to grow, adding further links to a site needs additional terminals and cables. A digital distribution or patch panel will also be needed to manage the now complex array of interconnecting cables. The resulting node solution requires a large amount of rack space, a complex array of cables, longer installation times, and of course, increased costs. And when the time comes to further expand the capacity of a link beyond 16E1, you're faced with limited options. Few wireless transmission solutions offer PDH capacities above 16E1, so there's little choice but to jump directly to an SDH solution. Now you need to replace the complete PDH link with a more expensive STM1 link. You'll also need a separate SDH multiplexer to interface the E1 signals to the STM1 payload. And if you haven't got one in place already, you may also need to look at a separate synchronization subsystem. Eclipse provides an optimized solution for building networks using only PDH technology. In addition to providing a scalable capacity architecture up to 16E1, each Eclipse Intelligent Node unit can support 1, 2, and up to 6 independent radio paths in a single compact chassis. But Eclipse can do more than that. When higher link capacities are needed beyond 16E1, EclipsePDH gives you software configurable capacity migration to 20, 32, 40, 48, 52, 64, and even 75 E1. That's up to 20% more than the capacity provided by STM1, but without the equipment changeout, without the expensive SDH multiplexer, without the need for additional synchronization equipment, and without the complex array of interconnecting cables. Eclipse's software scalable Super PDH fills the gap between 16E1 and STM1 and then goes even further. Eclipse Super PDH is the high-speed networking alternative to the cost and complexity of deploying SDH just for more capacity. Eclipse Super PDH eliminates equipment and drives cost out of your network. Eclipse gives you the ability to build powerful network node configurations using just a single indoor unit. The Eclipse Intelligent Node unit can support up to 6 independent radio links, with all traffic interconnections achieved internally under software control. Each Eclipse INU shelf includes slots for common and hot swappable universal system cards. The node controller card provides supervision and control of all node functions and regulates the flow of traffic between plug-in cards. A radio access card provides the interface between the INU and an ODU for each radio link. Installing multiple racks enables the node to support multiple radio links from the single unit. Traffic signals can be inserted and extracted at each Eclipse node using the data access card. Different versions of DAC are available depending on the number and type of traffic circuits that need to be locally added and dropped at the node. DACs can be fitted that support either TDM or Ethernet traffic, or a combination of the two. Installing additional radio paths or expanding the local interface capacity is as simple as adding modules and reconfiguring software. In most cases, changes can be achieved without affecting traffic already flowing through the node. With these flexible plug-in options, the Eclipse node replaces multiple radio terminals with a single optimized solution, saving on equipment cost and rack space. To see what enables the tremendous flexibility of the intelligent node unit, we need to take a look inside. An integral high-speed time-division multiplexed bus interconnects each card through the INU backplane. The node controller card controls the TDM bus and the timing of traffic flow between each access card. With a data access card installed, traffic can be locally inserted and extracted. Traffic from the DAC is routed by the TDM bus to a radio access card, which converts the traffic to an intermediate frequency signal that is then carried by standard coaxial cable to an outdoor unit up to 300 meters away. Traffic can also be routed between one rack and other installed racks. Two racks can also be grouped together for hot standby or diversity protection. In this way, up to 6 independent, non-protected radio paths, or up to 3 independent protected radio paths, could be connected to Eclipse INU for traffic aggregation and consolidation. An optional node protection card is available to protect the node controller card's management of the TDM bus and its power supply functions. Traffic circuits through the node can be simply added and configured locally or remotely by using the Eclipse portal or ProVision software tools. Eclipse simplifies complex network nodes by supporting multiple radio paths with software-configurable traffic routing and aggregation. With the integral TDM bus design, Eclipse helps you eliminate external equipment and cabling, allowing you to save on equipment cost and installation time, whilst offering higher node reliability. Save today. Save tomorrow. Switch to Eclipse.